Somewhere beyond the edge of our solar system, something massive is hiding. It's never been seen, never photographed, never directly detected by any telescope ever built. And yet, some of the world's most respected astronomers are nearly certain it's out there. A colossal world lurking in the darkness, silently pulling on the fabric of our solar system. They call it Planet 9. To understand this mystery, you have to go back to 2006, the year the International Astronomical Union dropped a bombshell on every kid with a solar system poster. They stripped Pluto of its planetary status. The AIU had established 3 criteria for planethood. You must orbit the sun, you must be round, and, most critically, you must have cleared your orbital neighborhood, meaning your gravity is dominant enough to either absorb or eject other nearby objects. Pluto failed that third test. It sits within the Kuiper Belt, surrounded by thousands of icy bodies it can't control. So it got reclassified as a dwarf planet, and our solar system officially went from 9 planets to 8. But here's where it gets strange. The demotion of Pluto didn't shrink our solar system, it opened a door. As astronomers began mapping the outer Kuiper Belt in greater detail, they noticed something that had no business being there: a pattern. Several distant Kuiper Belt objects, chunks of ice and rock orbiting far beyond Neptune, were all tilted in the same direction. They were all clustering on the same side of the solar system at the same time. The odds of that happening randomly are astronomically small, around 1 in 10,000. These weren't rogue drifters. Something was hurting them. In 2016, 2 astronomers at Caltech, Konstantin Batygin and Mike Brown, published a paper that sent shockwaves through the planetary science community. Their conclusion? The only thing that could explain this orbital clustering was the gravitational influence of an unseen planet, massive, distant, and completely undetected. Based on computer simulations and mathematical modeling, Planet 9, if it exists, would be roughly 5 to 10 times more massive than Earth, making it an ice giant similar in composition to Uranus or Neptune. It would sit 20 times farther from the Sun than Neptune, in a region of space so remote and so dark that sunlight arriving there would be tens of thousands of times fainter than what we experience on Earth. And it would be slow. At that distance, completing a single orbit around the Sun could take between 10,000 and 20,000 years. Think about that. A planet that started one lap around the Sun when woolly mammoths still walked the Earth might not even be halfway through that orbit today. 3 reasons, and each one is more humbling than the last. First, at that distance, Planet 9 reflects almost no light. It would be one of the faintest objects ever observed, fainter than many distant galaxies. Our telescopes have to be pointed in exactly the right direction at exactly the right time to catch even a whisper of it. Second, we don't know where to look. The sky is enormous. Searching for a dim, slow-moving object across billions of square degrees of darkness is like trying to find a single candle in a blacked-out football stadium, and you don't know which end zone it's in. Third, it moves so slowly across the sky that it barely distinguishes itself from background stars. Unlike most solar system objects, which clearly shift position between observations, Planet 9 may crawl so imperceptibly that it blends right in. Astronomers have come agonizingly close multiple times. Objects that looked promising turned out to be distant stars, faint galaxies, or ordinary Kuiper Belt bodies. Each false alarm is frustrating and also informative. It narrows the search. The most exciting development on the horizon is the Vera C. Rubin Observatory in Chile, a next-generation telescope that will scan the entire sky every few nights, capable of detecting objects
far fainter than anything current technology can spot. If Planet 9 is out there, the Rubin Observatory might be the instrument that finally catches it. Current models suggest Planet 9 may be near aphelion, the farthest point in its orbit from the Sun, which would make it even dimmer and harder to detect right now. But as it slowly creeps closer in the coming decades, it will get slightly brighter, slightly more detectable. The window is opening. This might be the strangest part of the whole mystery, because even if Planet 9 exists, its presence raises an immediate question. How does a planet that massive end up that far from the Sun? Planets form from the disk of gas and dust surrounding a young star. The farther out you go, the thinner and colder the material. A world 10 times Earth's mass forming at the solar system's outermost edges doesn't fit the standard model. Two leading theories have emerged. The first suggests Planet 9 originally formed in the inner solar system, near the other gas giants, but was gravitationally catapulted outward by a close encounter with Jupiter or Saturn in the chaotic early days of the solar system, flung to the outer dark like a billiard ball knocked off the table. The second theory is even stranger. Planet 9 might not be ours. It may have originated around a different star entirely, a neighboring stellar system that passed close enough to our young sun billions of years ago for our sun's gravity to reach out and steal it. It would make Planet 9 an interstellar immigrant, a captive world orbiting a star it wasn't born around. Both theories are plausible. Both have mathematical support. Neither has been confirmed. Here's what gives scientists the most confidence that Planet 9 is real. We've been here before. In 1846, astronomers discovered Neptune, not by seeing it, by noticing that Uranus wasn't behaving correctly. Its orbit had subtle irregularities that didn't fit the known planets. Mathematicians worked backward from those anomalies to predict where an unknown planet must be. And when telescopes turned to that exact coordinate in the sky, Neptune was waiting there. Planet 9 is following the exact same playbook. The math is pointing somewhere. The question is whether a telescope can reach it. What makes this genuinely unsettling is the scale of our ignorance. We can observe galaxies billions of light years away. We've mapped the cosmic microwave background radiation from the dawn of time. We've landed rovers on Mars. And yet, right here in our own solar system, the cosmic neighborhood we've been studying for centuries, there may be an entire planet we've never seen. If Planet 9 is discovered, it will be the most significant addition to our solar system since Neptune in 1846. It will rewrite the story of how our solar system formed, and it may reveal that even our closest cosmic home holds secrets we haven't begun to understand. And if the search turns up something else, something even stranger, well, that's how science has always worked. You go looking for one thing, and the universe surprises you with something it never promised to show you. The search continues.